So rules will be, so we take each set, let's go from bottom up. Okay. So take each item set and separate. Okay, and build rules from the item set. So the first is red, white means blue, right? And then red, blue means white, and then white, blue means red. So those are the rules that we can generate from this item set. Okay. Then from here it is red, white means green, red, green means white, and then white, green means white, green means red. Okay, so these are the rules from here. Okay. Now these rules, so again we have to split the item set in and then form the rules. So we start from, well, no, one more. So actually these three rules should come a little later. I was not finished with that. So here we split them with two items in the antecedent and one in the consequent, right? So now we also need to split this rule with one item in the antecedent. So red means white, comma, blue, then white means red, comma, blue, and blue means red, comma, white. And we need to do the same thing here with rules with two items as antecedent and one as consequent. Okay, so now we need one item in antecedent, two in consequent. So that would be red means white and green, right? White means red and green, and green means red and white. Alright, so that gives us the rules up to here, and now we need to look at these. I'm going to copy paste here so we don't have to scroll back up again. So this is the three items rules generated from three item sets, right? All right. So now rules from two item sets, and again let's go from bottom. So we have white means, so white means blue, and then the other way around, blue means white. Okay, so that takes care of that. And then white means orange, orange means white, and then red means blue, blue means red. Red means green. Green means red. And then red means white. White means red. Did I miss anything? White, I missed white, green. After orange, I went to. So I missed white, green. White means green. Green means white. All right. Okay, so we have all the rules now. So confidence okay, so what is confidence? Number of transactions or support. Support for the whole thing divided by support for the antecedent. So confidence here is red, white and blue. So we have red, white and blue divided by red, white. So that's the confidence for that rule. Okay. The next is red, blue and white, so that will be that divided by what? White. Did I do this right? Yeah. So red and white divided by the support for the antecedent, which is red and blue, which is that. So you need to look at, it's very easy, okay? The numerator must be all the items together, item set that contains everything in it. So white, blue and red. So white, blue and red is this. So that contains everything in it, right? Now divided by the support for just the antecedent. Antecedent is white and blue. So go to white and blue. So that's the confidence. Okay. All right. So
yeah. Say that there's a 50% chance that it's white and blue that's in your red.
That's right. So that's the probability of blue occurring if red and white is true. And that's 50%. So that's the exactly the probability, the conditional probability. That's what is called confidence here. Okay. So that I'm not going to go over the rest of it. So this is how you proceed with computing the confidence. So let's. So what we have done so far is generated item sets, frequent item sets. Okay, that's support for frequent item sets, and then we split the item sets into rules. Okay, how do you create rules? You take an item set, and split it into antecedent and consequent, and compute the confidence by looking at the number of transactions for the whole thing divided by the number of transactions for the antecedent. Yes. So that's your confidence. Now, of course, if confidence is high, then you have a high confidence for the rule is supposed to be strong. But sometimes if an item occurs quite a lot, okay, if one of the two or both, if antecedent occurs quite a lot or if consequent occurs quite a lot, then the confidence can be really high even though they are independent. So what we really want to do is to look at what is the improvement in confidence, okay, if the association rule is completely independent. What would be the confidence you would get? Okay, now what is the confidence we have computed? Okay, is it better than that or is it worse than that? So that's what this ratio is, lift ratio. You take the actual confidence divided by the benchmark confidence. Benchmark confidence is if the rule is completely independent, if the antecedent and consequent are completely independent, okay, so that would be the worst case, right? When they are independent, they have no relationship. There is no association. So what is the confidence of the rule when the antecedent and consequent are independent, no relation? So your confidence for the rule should be at least as much as that, okay? But sometimes it could be even less than 1, okay, which is really bad. So that's what we're going to do here. So what is the benchmark confidence? If antecedent and consequent, so this is your confidence formula, right? Everything at the top and just the antecedent in the bottom. Now, if antecedent and consequent are independent, then that probability is going to be the product of the individual probability of antecedent times probability of consequent, if they are independent. So now the probability of antecedent will get cancelled out, so what remains is probability of consequent. So probability of the consequent is your benchmark confidence. That probability of the consequent will be the confidence if the two are independent. If the antecedent and consequent are independent, then the probability of consequent will be equal to the confidence, and so that's our benchmark confidence, and we find the ratio, that's your lift ratio.